Hi guys, Buildzoid here, and we're back with yet more modifications for the ASUS RTX 4070 Ti TUF that I have. This time what I've done is add a whole bunch of capacitors to the Vcore power distribution network. Now, power distribution network is the fancy term for basically the connection from the Vcore VRMs over to the GPU core. And the reason it's called a power distribution network is because it's not just one power plane, right? Like on the back of the card, we have a Vcore power plane. On the front of the card, we have another Vcore power plane. There's almost certainly a big Vcore power plane on an internal layer. I'd assume on one of the two middle layers, there's just a massive Vcore power plane because on most high current PCBs, you're going to have at least two layers, and those are usually the innermost layers using 2-ounce coppers, 2-ounce copper instead of the 1-ounce copper, because that, like, the 2-ounce copper is just a thicker copper layer, so you can carry more current through it. And so, this calling like the connection from the Vcore VRM over to the GPU core a Vcore power plane isn't very accurate because there's multiple power planes making it up. These are all stitched together with vias. There's capacitors on the front of the card, the back of the card. It's a power distribution network, right? And so that's why it's called a power distribution network. Anyway, so I've gone ahead and added a whole bunch of extra capacitors to the power distribution network for the Vcore of this 4070 Ti, with the goal of hopefully improving the voltage regulation, which would hopefully translate into better overclocking headroom. I did manage to improve the voltage regulation, actually quite significantly. Like, I am surprised how much the voltage regulation improved. And I am more surprised how little it did for the actual overclocking headroom. It literally, like, if the card clocks any higher, it's within margin of error. And I've had cards in the past, well, I've had cards where cap modding them does nothing, both to the voltage regulation and to overclocking headroom. I've had cards where cap modding them gives you small percentage improvements, like I think there was a 7970 that I modified that would, like, stock PCB configuration, and admittedly that card was really old, so maybe the stock capacitors were kind of worn out, that kind of thing, but originally the card would hit like 1200 core, and then after modification it would hit like 1240, so, not a huge improvement, but we're talking somewhere in the, we're talking like 3-4% more core clock, and you can measure that. Like, that is something you can verify that, hey, if the card clocks 4% higher, you can prove that it clocks 4% higher. It's not that much of a problem. This doesn't clock it might clock 1% higher. It doesn't clock 4% higher. So, yeah, this, from a performance gain perspective, this was utterly pointless. Now, this being a modern NVIDIA GPU, there might be less clock stretching, just because NVIDIA GPUs deal with core voltage undershoot by clock stretching over it. So having better voltage regulation can lead to slightly better performance at the same clocks. But I didn't really consider that I'd have to, measure that. And so I don't have, really robust stock performance data for this card. And I'm not going to take those capacitors off again just so I can get that data, because that's not good for the PCB. Also, it's not good for the capacitors. It's really not good for the capacitors. The PCB would probably be fine with it, but you generally don't want to be, you don't want to be soldering things on and then desoldering them and then putting them back on. It's bad. That's bad for all of the components involved. Even what I've done here, even the first installation is not really great, but yeah. So I'm not gonna do that, and I'm happier to go with the current conclusion of the voltage regulation did improve. I can measure an improvement. Maybe there's an issue with my measurement methodology. Maybe the maybe the voltage regulation on the back of the PCB is very different from what the actual silicon itself is seeing. So maybe I'm seeing a really big improvement on the back of the card, but the silicon is actually still sort of, not the silicon isn't seeing that benefit. I find that kind of hard to believe, because as far as I know, BGA doesn't really have, BGA doesn't tend to have, a ton of impedance, I would hope. Right? If there was a really big, yeah, I would hope that the BGA of the GPU core doesn't have, a massive amount of impedance that, negates a lot of the benefit of these capacitors, but it could. yeah, the other option is like my measurement methodology is not great, but like this has worked for me in the past. So yeah. Anyway, so there is a very measurable core voltage regulation improvement on the oscilloscope, and in terms of overclocking, the card clocks the same. Is there less clock stretching? Probably, but I don't have performance data to back up the like to prove that the clock stretching has gotten significantly better. And the card clock stretches like NVIDIA GPUs always clock stretch. Like they're designed with the assumption of like there's going to be some amount of clock stretching, which is why NVIDIA has like a really aggressive DC load line of 0 V droop, right? Like, which I really was hoping to capture on the oscilloscope in one of the previous videos. Didn't manage to do that. We're still not going to manage to do that because this card's the card's too smart, basically. With some like on older NVIDIA GPUs, you could show the like load line configuration of an old NVIDIA GPU by just running something with a FPS cap, because you could see the GPU transition from idle to 100% load, and the core voltage would stay the same. You can't do that on I can't do that with this 4070 Ti, because if I put an FPS cap, the card just throttles the voltage, which is really cool from a like power efficiency perspective, but from a I want to test I want to investigate the power delivery behavior, really annoying. Like, because it just, like, the card will just throttle itself to maintain 100%, like, core load, right? Whereas on older GPUs, VSync would basically work by GPU renders a frame, then idles, renders a frame, then idles, renders a frame, then idles. Whereas modern, like, a 4070 Ti, like, it just clocks itself down until it's running at 60 FPS. Which is just like, well, that's not what I wanted at all. But anyway, so yeah, let's talk about what the modifications that I've made. So I've added 10 417 microfarad 3 milliohm ESR SP caps. So that's like this cap over here, this one here, these, you'll see, like, I know this kind of looks like it's stock. We'll get to that. These, you get the idea. So the SP caps are basically the big black rectangles. 3 milliohm ESR SP caps from Panasonic are basically the best SMD polymers that I'm aware of. These are 2 volts. Oh, I didn't mention that. Yeah, these are 2 volts. We don't need a higher voltage rating because it's a 4070 Ti. It runs at like 1 volt-ish. Right, so with capacitor selection, you just have to make sure that the capacitors are rated for a higher voltage than what you're actually applying them to. Right, so like you wouldn't put a 2-volt capacitor on a 2.5-volt rail, or even really a 1.8-volt rail. You probably wouldn't want to use a 2-volt capacitor. You'd want to use a 2.5. But yeah, this is Vcore on a 4070 Ti. The core voltage on this, sits at like 1.1 volts. So 2 volts, 3 milliohm ESR SP caps. These things they're kind of expensive, but yeah, they're really, really good. I'm like, I don't have, I've not tested a huge array of capacitors, but from the, like I've done kind of a lot of cap modding over time. These very consistently, like any card I put these on sees a big improvement in terms of voltage regulation, unless the voltage regulation was already incredibly good to begin with. So yeah, these are really great. I also added some 47 microfarad 0805 multilayer ceramics and 22 microfarad 0603 multilayer ceramics. So the 0805s, like you can see those up here, but I also put some behind the core. I'm going to take off the overlay. And yeah, I didn't wash the flux off of the card yet, just because I'm probably going to be doing more modifications to the card. And so, once I'm done with all the modifications, I'll wash the PCB. But for now, like, this is a no clean flux. It won't eat the card within like a couple days. So yeah. But anyway, so yeah, added some 0805 multilayer ceramics and some 0603 multilayer ceramics. Also here you can see the coax connection for Vcore. This is blue tack, by the way. That's not gum. So yeah, that's normally that's the main purpose of this is to like hang up posters on walls. But in my experience, it's very good at holding like oscilloscope probes in place. At least as long as the probes aren't too bulky. But yeah, so that's what I use it for a lot. Anyway, yeah, so those are the capacitors that I added. I didn't do anything on the front of the card because I didn't want to have to deal... Like, you can see how the coax goes over the spring brace. Yeah, I didn't want to deal with having to, like, desolder that because that would potentially... Well, in theory, if I soldered it like, if I somehow screwed up the soldering when reinstalling it, then it would, like, measure wrong. And actually, that's the reason, like, I used to do, like, I have these little, like, connectors that I use for coax, for connecting coax to GPUs sometimes. The reason I've sort of stopped using those recently is partially I'm running out of them, because they're, well, I think I attached a bunch of them to a bunch of cards, and then I didn't desolder them yet. But the other issue is that sometimes the connection will get loose, and it totally throws off the measurement. So it's one of those things where it's like it's more convenient, because you know you can just disconnect the probe from the card whenever, compared to soldering the probe into place. On the flip side, if it gets loose while you're trying to take a measurement and you don't notice that it's loose, your measurement is just completely screwed. So yeah, that's why I've sort of started soldering coax to things, even though it's way less convenient. Anyway, here's another angle of the modifications, so you can sort of see how the capacitors are stacked up. These are copper plates that I've soldered that are holding the stack together. There's not really... Well, I didn't stack anything on top of this one because getting in here with the soldering iron after I already built this little skyscraper, not really viable. I could make these skyscrapers taller. There's not really a, like, upper limit. It's just at some point you end up with a stack of capacitors so tall hanging off the back of the card that it's just really impractical. I guess I could also stack the capacitors, like, sideways and stuff. So, like, theoretically, like, I'm looking at this like, you know, I could do something along the lines of, say, this, right? And then the cap would attach like that. So yeah, that would make... Wait, I am so bad at drawing perspective. Screw it. It's a gold bar now. But yeah, so you get the idea, right? Like, theoretically, I could have added another capacitor like that, and then attach it, and then actually that could extend all the way to, like, here-ish. But well, it probably would still translate into some voltage regulation improvement. But the thing is, like, already everything I've done so far hasn't made a difference to the overclocking. I don't think a couple more polymers is going to really do anything at this point. Another capacitor configuration that I tested, just because it's easy to test, I didn't really have any high expectations for this. This is just a bunch of, like, through-hole polymers. And the thing about through-hole polymer capacitors is that they can get very low ESRs. Like, you can get 5 milliohm ESR. These are like a 7 milliohm ESR, but these are like a low inductance series from Nichicon. RS8s, I think. Yeah, low ESR, you have the RR5 series, and low ESL is RS8, if I remember correctly. Anyway, these are 560 microfarads, 3 milliohm ESR, and they're supposed to have a low ESL, which is equivalent series inductance, so they should be perfect for power filtering on something like a GPU. Except for the fact that, you know, they're through-hole polymer capacitors. These don't generally work that great, in my experience. Well, they work well on, like... like, I have them because they do work, but I did not expect them to achieve much of anything on this card, because this card already has a bunch of, like, SP caps on it, right? So, yeah, so even, like, low inductance through-hole polymers, like, they just do not compare to SMD polymers in terms of their, like, voltage, like, in terms of what they can do for voltage regulation. So I did this mostly, like, I didn't do this because I thought, oh yeah, this is a good idea. This is totally going to lead to some massive voltage regulation improvement. I did this because it's really easy, right? Like, through-hole capacitors are very convenient to install. It's not like they're not hard to put on the card, but at the same time, I wasn't really expecting them to achieve anything. I was kind of like, my thought process was like, well, if I do get an improvement, that's really cool and convenient, and I'm not going to take them off. But what ended up happening is they did okay, it wasn't absolutely nothing, but it was within margin of error of the stock configuration of the card, so basically nothing. And so I took them all off and replaced them with the configuration that's on the card right now. Also, you might be wondering why I didn't populate like here and here, and that's really simple. Again, it's just like once you get the soldering, like, you know, getting the soldering iron onto this pad after this capacitor's already here, not very convenient. Not very convenient at all, so I didn't do that. And I didn't use hot air on this because I didn't want to, like, thermally stress the PCB. Also, hot air, thermally stress the PCB is one thing. The bigger issue is also the polymers that are already on the card. It is extremely easy to cook polymer capacitors with hot air. At least in my experience. Maybe I'm just really bad at hot air soldering, but, like, yeah, I am not installing polymers using a hot, like, with a hot air. Like, I'm just not doing it because technically that would be the correct way for, you know, installing SMD components. But in my experience, that's the fastest way to accidentally cook a capacitor, and they smell really, really bad. Also, well, the funny thing is, cooked capacitors do still work, in my experience. They just work far less effectively, and they smell bad. So, yeah, I wasn't going to hot air this into, like, I wasn't going to hot air these into place, and that's why, you know, I skipped, like, these, so that I could get the soldering iron onto the pads to get everything soldered up. So, yeah, that's what the modification looks like. Not really, like, not super difficult to do, but the thing is, like, the benefits are borderline non-existent. So anyway, let's take a look at how the card behaves now. So here we have it hooked up with the oscilloscope, right? Also 100, yeah, like full bandwidth on the oscilloscope again. The settings we're running is a plus 182 on the core, plus 1000 on the memory. And we're just going to run TimeSpy GT2. And we're going to run it TimeSpy Extreme more specifically, and it's just going to be looping. And so in the stock configuration, the card would run, well, I'll actually wait for it to load up. Yeah, so you can see we're running at around 3 gigahertz-ish core clock. And I'm just going to reset the statistics. So, am I actually going to just grab the light? But nah, I'm going to use the pointer thing. Average voltage before the modification was 1.0866 volts. So that's basically the same as this 1.0868. Also, if we wait for the benchmark to run, this will eventually reach 1.0866 volts. So, yeah, we wouldn't expect to see a difference in the average. Well, no, on an NVIDIA GPU, you wouldn't expect to see a difference in the average voltage. There are some cards where reducing the overshoot will actually bring the average voltage down. Because because of how the average voltage is calculated, right? If you, like, slash a bunch of overshoot off, your average voltage will come down. So yeah, that's sort of a funny thing. But this is, like, this average voltage is within 5 millivolts of what it was before the modification. And in fact, right now it's reading a bit high, maybe like PCB temperature or something. So yeah, anyway, close enough. Oh, I think I see why the core clock didn't improve. Anyway, wait, did it really? Huh. Evidently, I wasn't paying much attention. Oh, I know what I did. I made the mistake of looking at the peak to peak. And this is why we shouldn't, like, I should just not have the peak to peak monitoring. Anyway, so yeah, average voltage is about the same as before. Now, minimums. This is the part that actually matters, right? Because if you're undershoot, like, if at any moment during a frame render the GPU isn't getting the voltage it needs, it's not going to be able to render the frame, right? Like, it's just going to crash. So, all average minimums are a pretty substantial improvement. Originally, the card would run at around 976 millivolts average, right? For like average undershoot would be like 976 millivolts. Now it's 999. It's basically a volt. So we see like a 24 millivolt improvement in terms of average undershoot. Actually, wait, no, there's still an improvement. It's just not that big. Yeah, and the minimums are down at like now we're getting 986. This is like the worst minimum recorded so far. Admittedly, earlier there was like a 980, but yeah. Originally, the card would bottom out at like 962 millivolts. So yeah, we're seeing like a 24 millivolt improvement. So really, yeah, it's like 24, 23, like 20-ish millivolts across the board improvement in terms of undershoot. So, you know, like that's something. It's just not very much. Oh, there we go, 983. So yeah, it's like 20 millivolts of undershoot reduction. And then like the peak to peak is the part that I got excited about, and it's like, oh wait, I made the dumb mistake. Because the thing about the peak to peak measurement is it's from the top of the waveform to the bottom of the waveform, right? So if you chop off a bunch of overshoot, which doesn't cause stability problems, you get a big improvement in peak to peak. And you can feel good about yourself. While the card clocks exactly the same, because ultimately what determines max frequency is your minimums. So maybe I should just throw more multi-layer ceramics at the card. The thing is, I'm actually kind of running out of multi-layer, and I'm now tempted to throw more multi-layer ceramics at it, though. Then again, 80 like an average voltage of like 1.086 with a minimum of 1 volt would be kind of insane. Like that would be very, very good voltage regulation. Like that, yeah, that would be really, really good. Oh, and we've got a 979 now. Oh, well, anyway, peak to peak, originally, on average, so this measurement right here, that used to be 221 millivolts. Now it's 176. So, you know, like a 50 millivolts reduction in average peak to peak. And worst case scenario, peak to peak used to be 245 millivolts. Now it's 197. So there's like, you know, a 50 millivolt reduction in peak to peak, which sounds really impressive until you consider the fact that it's caused by like a 30 millivolt reduction in overshoot, which translates to exactly 0 improvement in terms of overclocking. The other 50 millivolts is due to the 20 millivolt improvement in undershoot, but unfortunately that's not a big enough improvement to drastically increase the overclocking headroom. And honestly, I don't think even if I did get the minimums all the way up to a volt, that we would be seeing a... Like, I still don't think that would be enough to push the card into doing, like, consistently over 3 gigahertz. Or... Well, no, I think... I still don't think that would be enough to, like, a big enough improvement to be, like, to justify the effort. I am still kind of tempted to try more multi-layer ceramics, though. Yeah, I am kind of tempted to, because... Oops, no, that's the wrong knob. There we go. This is the right one. To kind of zoom in on some of what's going on here. So, that's kind of the thing, is like, so there is a voltage regulation improvement. It's just not big enough. And most of it was in the peak to peak, which is why I got so excited. Man, like, this is a mistake I've made in the past. That's what I get for putting the peak to peak measurement back on. I swear, like, that is a measurement we, like, that just shouldn't, like, Well, okay, no, there are use cases for the peak-to-peak measurement, but what I'm doing here, the peak-to-peak measurement doesn't matter. So I should just not use it. But anyway, yeah, so this is how the card runs now. So, yes, the voltage regulation, like, there's less peak to peak, which, from one, like, within one definition of voltage regulation, that's like, it's an improvement. But yeah, in terms of actual overclocking headroom, it hasn't changed. And performance, due to, like, clock stretching, might be very slightly better, but like I mentioned at the start of the video, I don't have robust enough stock performance data to compare to sort of consider the clock stretching improvements, or to test for clock stretching improvements. That's the way I should have worded that. Anyway, yeah. So, I mean, I had fun installing capacitors, and it was like I did figure out I slightly changed my technique for installing multi-layer ceramics with this card. So, from that perspective, it's like, yay. From a perspective of, hey, does this actually help performance? No, it didn't. Anyway, one neat thing that I noticed while doing all of this testing is that ever since this card doesn't have a power limit, the core voltage slider actually affects the core voltage a lot. Check this out. That's a 50 millivolts core voltage bump. Also, the card has a cooling problem that I need to fix. Also, that cooling problem has been present for the entire voltage this card's had like a cooling problem ever since I got it. Like, the hotspot on it runs really hot. Initially, I thought that's actually just how this... Well, I think it might... There's something wrong with the cooling on this card, so I need to fix that. And, yeah. Now, the reason I haven't fixed it yet is because if I fixed it now, if I fixed it, if I ran the card with bad cooling, and then I fixed the cooling and did the cap mod at the same time, it would invalidate any if there was an overclocking headroom increase. How do you know it's not the cap? Well, how do you know if it's the cooling or the cap mod, right? So, anyway, yeah, but one of the issues with the card right now is the max. So if we look at the max core temperature right now, right, it's like 75, and the max hotspot is like 94. And now it hits 97. And, well, if I crank that core voltage slider, also it's hit 100. Admittedly, the room is quite warm. It's summer, so it's like 26 ambient, 27 ambient. But anyway, yeah. Immediately hit the absolute thermal limit of the card. Right? If I raise the temp limit. So... And you can actually see it like thermal throttling because of the core voltage, because of the hotspot getting just completely maxed out. So, yeah, I need to do something about the cooling on this card. Voltage regulation's a lot better than it used to be, so hopefully, like, if I figure out a fix for the cooling, because I'm not sure, like, it might be a... Like, I've repasted the card since I got it. Like, when I got it, the hotspot already was running hot compared to the average temperature. And that didn't change when I repasted the card, so I just kind of figured, like, that's just how this card runs. But I've looked at some data on the internet, and my hotspot delta seems to be higher than it should be. So maybe the thermal pads are too thick, or the base of the heatsink is really garbage, or... Yeah, I need to find a fix for well, I don't need to find a fix. But if I want to push the card harder at this point, then yeah, I need to do something about the hotspot temperature, because, like, I can't believe it. The NVIDIA placebo slider actually changes the core voltage. And when the core voltage gets raised, yeah, this just completely overheats. So I need to do something about that. Anyway, so yeah, that's it for this video. That's the cap mod on the 4070 Ti. Big peak-to-peak reduction. Not a very big improvement in overclocking headroom. So I guess it makes sense that ASUS shipped this card with a bunch of unpopulated capacitor pads, because I imagine, well, okay, I'm not 100% certain that ASUS would have tested for this, but if they did, they probably noticed, hey, populating all of the, like, populating absolutely every single capacitor mount, not actually worth it, because the card still clocks the same, right? So, yeah, that's it for the video. So hopefully you found it somewhat interesting, if it's admittedly not very useful. But because this was a total, like, like, it didn't do anything for the performance, so I think we can all agree this was a waste of time. But, yeah, hopefully you found it interesting. So that's it. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, hoodies, posters, you know, the usual YouTuber merch. And I've also got a Bandcamp. There's a link to that down in the description below as well. And yeah, that's it for the video. So thank you for watching, and goodbye.